Hi, everyone, and welcome to day 4 of the rigging workshop. My name is Matt Ringo, and today we are going to cover the fundamentals of modular rigging. A little bit about me. I am French, but I live in New Zealand, and it's actually 4 a.m. for me right now. So, a little disclaimer if there is a few yawns, I am so sorry. I'll do my best to stay awake, I promise. But yeah, so I am French. I studied and started my career in France and then quickly moved to London in 2012 to work in the visual effects industry. In 2016, I joined Weta FX as a creature TD. And in 2021, I opened Unreal and digged into Control Rig for the first time. I made this little T-Rex here in the middle and absolutely fell in love with Control Rig. And I'm still in love with it today, actually. So in this actually gave me the opportunity to join the Weta FX special project team, where I worked on a few real-time projects, such as this little octopus here, fully animated and rigged in engine. And this was 3.5 years ago. So when someone tells you, "Hey, we can't really animate stuff in Unreal," well, this is not right. We can, and we can also animate some very complex characters. On top of that, I worked on War is Over for almost a year. This is the short film here on the right. We actually won an Oscar for this, so it's the first short film made in Unreal that won an Oscar, which is pretty exciting. And I worked on the GDC demo in collaboration with Epic and Weta here on this big robot, all rigged in Control Rig as well. And basically, all these gave me the opportunity to join Epic in October 2023. So it's going to be my 2 years anniversary as a senior technical animator to be part of the Lego Fortnite team. So this is me today. And I just want to say that I'm really excited to be here with you today. It's not often that you have like opportunities to share some knowledge with some kick-ass professionals. I would say that I know probably most of you, if not all of you, already have experience with Control Rig and most likely with some modular rigging as well. So today we're going to cover the fundamentals. I hope you're going to still learn something. And if you don't worry, we will get you covered on the workshop at the end, with all the questions. So we have a lot to cover. And on the schedule today, we are going to create and convert modules. And this will consist of making a FK chain module, a root module, a limb module, and a spine module. Through that process, we are going to discover the modular rigging interface, where we are going to assemble all of our modules. We're going to work on some control rig function libraries to share public functions across multiple rigs. And we're going to look into module metadata as well. So modules can talk to each other without having to expose everything at the top level of your module. And we will look at the best practices for module versioning, tagging, and module swapping. And hopefully, this will lead us to a fully functional modular biped rig by the end of this class. Okay, so a few things about modular rigging. Obviously, why? Why is this a thing and why should you use it? Well, having modules makes it way more reusable. Okay, obviously, you can build one module, arm module, and if you have a character with 6 arms, then you use the same module. You have one place to change everything, and all your 6 arms will be updated. But not only that, as you can see here on the middle image, it's the construction graph of our biped rig, and it's quite pretty decent. And those graphs can get massive. Obviously, the more complex your rig is, the more complex your graph is. So with modules here on the right, we can see the construction event of a single module. So the graph being way smaller, it's easier to iterate, it's easier to debug, and it's also something that we'll look at the end of this class, easier for version control. But not only that, I would say that not everything needs to be modular. Things such as very character specific control rigs, let's say a prop rig, a gun rig, for example. You don't need to create a module and then a modular rig for this prop rig if you know that this prop rig is not going to be reused. Like a specific module in there needs to be reused. you can still use a standard control rig. That's totally valid. The one thing I'd say though is that if you end up like us, so at Epic now we do have quite a decent library of modules. So I would say that all of our rigs, almost all of our rigs are done with modules. But for character specific needs, we end up doing character specific modules that then get bolt on onto all of our other modules, which is pretty awesome. So your library will keep growing and you'll be able to share that across multiple characters. Okay, so the modular rigging interface, we've decoupled it in 5 different sections. The first section on the top left corner here is the module assets. And this is where you're going to have all your modules display where you can take them and drop them into your viewport. In 2, we have the module hierarchy, where this is defining the hierarchy of modules, but not only that, it's also defining their evaluation order. So it's super important, and we'll get to that at some point. In number 3, we have the viewport, where obviously you're going to play with your controls. You're going to drag and drop your modules on the schematic and all that. And then on the number 4 is the details panel. The details panels is where you're going to see the options for your module. So when you select it in the module hierarchy, you will have their options available here. And those options consist of the connectors, which will touch base, and the options that you have exposed at the top level of your module. So any public variable will show up here. And this is how you alter specific settings on your modules. And in 5 here, down here, we have the rig hierarchy. And this rig hierarchy is obviously going to display all of the controls, nulls, and bones that are either generated in your into your modular rig. Excuse me. Okay, so you know what? Let's go to Unreal and let's create our first modular rig. So in the project, in day format, we are going to right-click, animation, advanced, no, control rig, control rig. Okay, here I have the choice. I have either the choice for a control rig or a modular rig. What is the difference between these two? Well, a modular rig, think about it as a container where you're going to put all your modules in it, set specific settings, and save it. This modular rig does not have a graph, so you can't add extra logic within that modular rig without creating a module. So in this case, we do want to create a modular rig. And when I create this, and we're going to call it MR for modular rig, not for Matt Ringo. When I started working on modules at Epic, I put MR everywhere, and they were like, "Why you put your name everywhere?" I was like, "This is not my name. This is Modular Rig." And for the fun part, we're going to call it Mr. Robot. So today it's going to be Mr. Robot. And the first thing we see here is nothing. Okay, well, the reason why is because we need to set these skeletal mesh into our previous settings up here. So when I set the skeletal mesh here, we can see that now I can see my asset, which is great. And I can also notice that it has created some controls for me already. And this is because it's automatically adding this root module. But today we are going to create our own because there's a few things I want to show you. So we're going to delete this for now. And we are going to compile. Okay, well, we have our modular rig. That's it, guys. No, I'm kidding. Obviously, we don't have any modules here and we need to build them. So let's build our first module. And the first module for today is going to be the FK chain module. It's a pretty simple module, but there's a few things that we need to go through. And you guys have done awesome work with Ferris on the first or second day, sorry, which consists of creating construct FK, forward FK, backward FK functions. We are not going to do that today. We're not going to redo this. Don't worry. I think that you got it, so that's all good. But what we're going to do is we're going to port over those functions. So the principle of this class really is to show you how you can convert existing rigs and move them into modules or create modules from scratch as well. So when we look at those functions, I like to kind of like decouple things a little bit. We have inputs and we have options. So inputs in this case, we'll look at the parent and the bones. So the parent will be where we are going to parent our FK controls to. And the bones are simply where we're going to create an FK chain onto, right? And then we have rotation orders, shape settings, and maintain offset. And I like to put those ones into more of an option category. So these can be exposed at the top level of our module, And so we can change them based on if it's a right arm or a left arm, we want different rotation order or, whatever, or the shape settings. So we will do that. Okay, so let's have a look-see, and then we're going to create this module from now. So in day 4, I'm going to right-click, new folder, and do modules. In this module, we're going to right-click, animation, control rig, control rig. Okay, we get back to this little screen here. What did we just say? Do I need a control rig or a modular rig? Well, if you said modular rig, you got to pay a little bit more attention. I said we need to have a graph, right? So we need to pick up control rig and not modular rig, because our module obviously will contain all the rig logic. So let's create this, and then we're going to call it CRM for control rig module, FK chain. Okay, I open this bad boy. There's nothing in it. That's fine. First thing we're going to do is change our preview mesh and set it to SKM robot simple. Then I go into my rig hierarchy, and there is nothing. Okay, so I could use this import skeleton, like Ferris has shown you, to get my hierarchy procedurally imported. But today I am not going to do this, because we are going to go at the top here, and we're going to click on switch to rig module. And if you keep an eye on this rig hierarchy, 1, 2, 3, if you blink, it's too late. Okay, we have now our rig hierarchy. Look at this. And you can also notice that it is imported procedurally because it's in yellow and not in white. It's a good way to define that. It means that if I change this SKM to any other SKM, this hierarchy is going to change automatically. And this is obviously needed for our modules, right? Because we want our modules to adapt to any kind of skeleton. And for this to work properly, let's say when we do a get transform, usually what we have done so far is we have specified, let's say, a bone and say, okay, now you can use this bone and then I can get my transform. But if I do this and I change my SKM and the name of this has changed, my whole rig is broken. And that's what connectors come into play. So if we look at the top here, when we switched it to rig module, it has created a connector, a root connector. Think about a connector as like a placeholder or a tag for the actual data. Okay, so I can take this connector, drag and drop it anywhere I want. And basically, I can use this connector to actually do my rigging. Okay, so in this case, I'll do right click, get connection. I'll find my root. So this is my root connector. Obviously, we can name this whatever we want. And then now I can use this information here instead of the bone name, right? So now this can be drag and drop anywhere we want. And it will point to the actual bone link to it. So my rig will not break. Okay, well, let's have a look at connectors. We have 2 types of connectors. We have the primary type, which is the one that is automatically created when you are converting to module. This primary connector is not optional, cannot be optional. You cannot delete it either, and it needs to be resolved for the module to work. The other type of connector is secondary connectors. And these secondary connectors have a few options or a few settings. The first one is optional. So the optional option is basically you have this connector, but it doesn't need to be resolved for the module to work. And we will show that on the next module. Then we have a isArray connector, which is where you want to specify multiple bones on that single connector instead of creating how many connector. And we have a bunch of rules, okay? So let's have a look at the connectors that we need for our FK chain module. If we look at the bottom here, we have 3 different connectors, parent, start, and end. The first one is our primary connector. Our primary connector, we're going to call it start, okay? We know that we need bones, but I don't want to specify a connector for each of my bones, or I don't want to create a connector array where I have to specify all of my bones into that connector. What I want to do is I want to give a start, I want to give an end, and then I want my rig to automatically find all the joints in the middle and simply return that as a list of bones. So we have our start, which is our primary. We have our end connector, which is not optional and is not an array, but it has this rule. This rule is called child of primary. And this is important in this case because our end connector definitely needs to be a child of the primary in order to find the chain in between the two, right? So far, so good. And then we have the parent connector. The parent connector is where we are going to parent all of our FK control to. So this one is, again, not optional. It's not an array, and it doesn't have the rule. Because if we put the child of primary rule on the parent connector, well, it can't be above the start, right? So we make sure that we don't have this rule here. Okay, let's create this. Just going to have a quick sip of water. Nice. Okay, so we said a start connector, and it's our primary connector. So you can click on this and you can do F2 to rename it. What I'm going to do first is I'm going to drag and drop it onto my leg. So then it's all ready for a leg rig. Okay, cool. And then I'm going to right click on my ankle, say new element, new connector. And then right now we're going to rename it end. If I click on it and go into the details panel, I have a bunch of options here. And that's where I'm going to say, I don't want it to be optional. I don't want it to be an array, but I keep the rule child of primary. Now I can right click on the connector parent, a new connector, sorry, and create a parent connector. And this parent connector here, again, not optional. And in terms of rules, I said I don't want any, but if I wanted, I could add a type rule, for example. And this type rule would mean that I want it to exclusively be a control, a socket, a bone, or whatever you want to. So in our case, we're not going to need that. So I'm just going to delete it for now. Okay, nice and easy. We have our connectors. If I go into Mr. Robot now, I see my beautiful module. Stunning. I can take it and start drag and dropping into my viewport. And you can see here all the schematics here. So it's basically showing you the bones that you can drag and drop it here. So I'm going to drop it on my leg. And I would click on my connector. And I can see that I've got the start that has been set automatically. So it's when I'm dropping onto a specific bone, it's setting this primary connector. But the parent and end connector are not defined. So I could technically come here and then scroll down and find the bone that I want to and things like this. But it is a bit annoying, isn't it? I want to benefit from that drag and drop feature. I want to be coming here, drag and drop, and then resolve this connector so that my whole rig is built in a second. So for that, in the modules, we have a new event called the connector event. So I'm going to create a new graph, and we're going to call it connector event graph because we like keeping things tidy. And we are going to create this connector event. Oh yeah, let's go. So we have connector event, and what is this thing doing? Well, this event is running on every connector once. Okay. So what we can say is, hey, when you are on the end connector, find all the children of our start and give me the last, basically. So then it can automatically set this end connector for us when we drag and drop. So to do this, we're going to go get candidates. Okay, so this will tell me the output pin of this will tell me which connector this event is run on. So I can say if this connector is equal to my end connector, so I'm going to do get connection here and there, beautiful. Oops, sorry. So now I'm saying, okay, now the end connector, the connector this event is run on is currently the end connector. This is great. So if it is, what I want to do, I'm going to create a branch node, and I want to go and say get connection, give me the start connector, find all the children, get children, make it recursive so it includes it. That's cool. And then it's going to find all the children here, but I want the last one. So I'm going to say a and -1. Nice. Select them all. Hit Q if you don't know that. This is amazing. If you're OCD like me, you will love this thing. Okay, so that's nice and clear. And then what I want to say is I want to say set the default of this end connector now. So I'm just gonna make this a bit bigger for you guys. It's not big enough. Um, Set default match. Oops, not this one. Set default match. Nice. We can plug this in the true here, and we can plug that here. Okay, if I compile and go back to Mr. Robot, I can drag and drop. Look at this. It has set my start and it has set my end connector automatically. Beautiful. It has found all the children, get me the last one, and connected it automatically. So I could do the same with the parent connector. Let's do it. We copy this graph here and we're just going to paste it underneath. Nice. And we are going to set this to be the parent connector. So if the current event that is running on is on the parent connector, instead of getting the children here, we're going to get the parent. So get parent. We can delete this logic here and we can connect this up. Okay. Now we've got these two. Let's make a clean graph with our beautiful sequence node, super handy, and a little reroute because we want things tidy. Again, I'm pretty OCD, but it's okay. We're not going to spend too much time on this today, I promise. I'll do my best. Okay, so compile, Mr. Robot compile. And what I'm going to do again is drag and drop because really this is to benefit from the drag and drop. Are you ready? 3, 2, 1, boom, let's go. We have a start, a parent, and an end connector automatically defined. And now if I have this chain, I want to drop it on anything, it's going to build that whole chain. But right now it's not doing anything because, well, we don't have any construction that actually builds any control. So let's go into the construction event and we're going to steal today. We're going to steal a lot today. So we're going to day 2, open Ferris's rig that he has beautifully prepped for us. And in the construction here, we have the construct FK function. So let me just grab this. What I'm going to do is I'm going to put this on a separate window so you guys can see. Nice. So on the left here, we have our FK chain module. On the right, we have Ferris's work. So I'm going to grab this construct FK. I'm going to hit Control C. And in my graph here, I'm going to hit Control V. And here, I want you to be really careful. What I've done here is I've copied this function and pasted it into my graph. But you can see it has created a collapsed graph. It has not created the function. So we don't want this. We want to make sure that we are getting the function. So in order to do so, I'm going to click anywhere else than in the graph and hit Control V. And now you can see it has created the function down here, which is great. And I can see that something looks a bit off here. So a pen is missing. So let's have a look at what Ferris is doing in here. So he's using a conform name function, which somehow this didn't pick up. So let's go into here and grab the conform name function, Control C, Control V. Okay, cool. I can go back to this construct and I can set it back. We're just going to hook this up. Okay, that's fine. No biggie. But be prepared that if you're converting some of your modules, you will have some stuff like this. So make sure that you dig into your functions and make sure that all the connections are there. And you will see through this class that it will happen a few times. Okay, so we have the construct. Now I can go back to my construction event and I can drag and drop this beautiful function. Thank you, Ferris. This is stunning. Okay, so when we look at this, we have the parent and we have the bones. So far, so good. We know that we can use the parent because we have the get connection. We have our connector event, parent. So I'm going to do parent here. And for the bones, as I said, I want the chain between these two connectors. So I'm going to do a get connection. I'm going to find the start. And then I'm going to duplicate this. And I'm going to find the end connector. Okay. The thing here is we know that the forward FK will also use some of those. So we might as well just store everything into variables. So here, between the start and end, first of all, let's do the get chain node. Get chain node, you give it a start and end, and it will give you all the bones of that chain. So perfect. And we want to store these into variables. So I'm going to pull from that pin and say promote variable. And I'm going to do the same with the parent, promote to variable, hook this up. Select this stuff. Oops. Hit Q. Nice and easy. And then Shift D, by the way, if you want to line up horizontally as well. And then now that they are stored into variables, let's rename these property because this is not quite what we want. So the first one is we said parent, and the second one is sorry, actually, this is bones because this is the array, and this one is the parent. Nice. I can compile, beautiful, and I can use those. So parent, bones, get bones, and hook this up. Okay, so far so good. Nice, compile. Zoom into my module a little bit. And look at this. We already have controls. Oh, yeah, stunning. Okay, these controls do nothing. Let's go back quickly to our Mr. Robot and let's see here. Okay, that's fine. So we have our controls that are created on our old chain, which is what this module is doing, obviously. But what about, I want to change the rotation order. I want to change the control shape of this because if I have multiple times this module multiple times on my rig, I want to make sure that all the settings are specified at the top level. Well, pretty simple because we have this great work here, almost done, almost feel like it was done on purpose. It was done on purpose. We have this rotation order and the shape setting. So I'm going to pull up from this pin and I'm going to say promote to variables. And I go back to my graph, my blueprint here, and I'm going to rename them properly. And the thing I want to do is I want to click on this little I here. And this little I here will make this variable public. So now if I compile and I go back to Mr. Robot and I click on my module, these are now visible at the top level here. So it's really easy for me to change things like the control shape, like the color, or the rotation order. So that's how we expose things to the top level of our module. This is so easy, right? So now that we have that, this is great. But obviously, if I grab one of this control, it's not doing anything because we don't have a forward solve. So our construction, we're done. It looks great. Do that quickly. And then we're going to create this construction now. So let's go into not our construction, our forward solve. Let's go into our forward solve. And we're going to go back to Ferris's work. And we're going to steal more functions. So we have the forward and we have the backward, right? So we need these two. So I'm going to steal them now. Control C, Control V. It has created it. Double check your function. Everything is working. Beautiful. Grab the backward FK, Control C, Control V. Check your function. Everything is working. Beautiful. Okay. So I'm going to go back into my forward solve. I'm going to drag and drop this forward FK. And now you can see bones. Well, I know that I have bones, so I am just going to do this. Nice. And I have this maintain offset. So I might as well just expose this as an option as well, because this could be handy and will be handy later on. So we're going to rename this and make it public. Okay, nice. We're going to do the same for the backward solve, sorry. So here we don't have a graph. I am just going to create it. And a little trick here, if you create a graph and you go here and you go backward solve, so you create the event, boom, it has renamed the graph for me. So automatically. So you see if I delete it, it renames it to rig. If I go and add this event, it automatically renames it for me. Stunning. And then now I can go and look for my backward FK and do the same. We're grabbing the bones, we're grabbing the maintain offset, and we do this. Okay. All right. So we can compile. And what I like to do is having this a bit cleaner. You don't want all your variables like this because it can get pretty big. So let's make this a bit clean. I'm going to call this one in a private category because these ones are only used and they're private. They're only used locally. And these ones are module options. So I'm not going to put them into a public because, well, it's just makes more sense and it's cleaner if I do that. Module options. I'll show you quickly. If I compile this and go back to Mr. Robot and click on my module, you can see that I have put one into the module option category and the other ones are into the default category. So that's how you can categorize your options and get them displayed nicely. So we're going to put all of those into our module options, and you can drag and drop them here as well. And you can also reorder them. So if you reorder here, beautiful. Nice. Look at this. We have our module options. If we grab this control and we rotate, yep, it's working. Thank you, Ferris. This is great. I like it. We have done our first module. Well done, guys. So we have set a bunch of connectors and created a bunch of connectors. We have created the connector event to benefit from the drag and drop. Okay. And in this case, we have specified the end connector. Then we have specified the parent connector to get the parent from the start automatically. We have stored all of these into variables, and we have added the construct fk, the forward fk, and the backward fk functions. And then we have a working fk chain. So, few things about module conversions. We saw quite a few things here, but I just want to recap that. So create the inputs and module options. So look at the functions that you are going to convert and make sure that you have all these options created. So that you have the variables needed for this before you copy over. So all of this stuff. And we have, created local variables. We have created our connectors and promote them to variables and created the optional connector graph. So again, the connector graph is only for drag and drop. It's not a requirement. You don't need to create one, but for your user, it's pretty awesome to just come in here and say, okay, well, just build me an FK chain. Boom, look at this, FK chain done. That's pretty epic. I love it. Okay. So this module is done. Let's move on to the next module. And we're going to look at the root module. And for the root module, I already had a sneak peek at what Ferris is doing. And I'll tell you right now, he's using the forward FK and the backward FK function again. Okay, so the root module is going to be pretty simple. It's creating a global and a local control, and also a body control that will be placed in between the hip bones. But for driving those bones is using the forward FK and backward FK function. Okay, well, we've seen that we've already copied this function from his rig to our module. And for this module, I actually don't want to copy this function again. Like, why should I have multiple versions of this same function in like n number of modules? Well, to mitigate that, we have control rig function libraries. And control rig function libraries are basically a control rig that doesn't have any specific logic in it, but it just contains a bunch of functions that are set to public. And these functions can then be accessed by all the rigs that you need them in. So we are going to create this control rig function library. We're going to have our construct backward and forward FK functions. We're going to put them into a very nice category, and we're going to set them to public, and we're going to swap that into our FK chain. So let's do that. Let's go back into Unreal. In our project, we are going to go to day 4, mat, and we're going to right click, new folder, CRFL for control rig function library. The reason why I'm creating a folder is because you might end up with quite a few of those if you want to do things properly. So we're going here and we're going to create a control rig because we need the graph, obviously. So let's go create control rig called CRFL utils. Yeah, I know there's not really more generic names than utils, but everyone has a utils at some point. So let's just start it from scratch. Okay, CRFL utils, we are going to delete that forward solve because we do not need it. And then we can compile. And what I'm going to do is I'm going to separate these two windows so we can see it nicely. On the left here, we have our beautiful FK chain module. And on the right, we have the CRFL utils. So let's grab the construct FK, but we remember that when we copied the construct FK function, this little pin broke. So let me try to get the function first and see if that works. I grab this conform name function, copy paste. Get the construct FK, Control C, Control V, and it's broken. So We're going to talk to our devs. Don't worry. Let's have a look. This should have come through, but it's okay. Okay. It's only taking a few seconds to reconnect. But that's my point of always make sure that your functions have been copied over properly and everything is connected properly. Okay, so we've got these two when I do the forward FK and the backward FK. Okay, we got all of our functions into our control rig function library. Let's make this bigger. And what I want to do is right away, I want to put them into a specific category. And the reason is because you will see when we are going to use them, it's going to be much nicer to have them in their own category. And the category that I like to put first is the actual name of the CRFL. So you know where they are stored in. So this one is going to be into a naming category because it's the conform name. And then for these, we're going to put them into CRFL utils FK category. And you can separate your categories with this little vertical bar. I don't know what's the name in English. Sorry, I'm French, remember. So we have that backward solve and same for the forward solve forward FK. So cool. So if I now close this CRFL utils, everything is properly underneath, which is nice. And then what I forgot to do is set all of these functions to public because we want them to be accessed into other modules. So let's just set these all to public. One little tip here, you see I'm clicking on public, but this widget is not going away. So you can wait for 10 minutes here if you want to, but actually it's never going to go away. So you have to click somewhere else, but it's actually setting it to public. So no biggie. It's just a little buggy. Okay. So we have our CRFL utils set up. I'm going to drag and drop here, expand this back and go back to our FK chain. Well, let's have a look. So in my forward FK, and note this one, because these are my local functions. I'm going to close this a bit. In my forward solve here, I have this forward FK that is using my local function. So I can right click and I can look for forward FK. When I look for forward FK, I can find two now. I can find this one that tells me that it's currently in my current module. It's a local function. And I can find the one in my CRFL utils. And that's where the categories are really important. Because when you end up with a lot of functions, you want to make sure that they are stored and categorized nicely. So now I can see that this one is my CRFL utils. And I can just pick this one up and it would tell me where this function is coming from. And I can just hook this up again. Okay, beautiful. Stunning. And take this, delete it, make it nice, compile, just make sure this is working. Yeah, it is working. Okay, well, let's do that with our construction. But here there's quite a lot of pins. I don't want to reconnect them manually. Actually, this looks weird. It shouldn't be CRFL utils already. So it should be, let me check. It should be construct FK. Don't know how this happened, but I just want to show you a little trick. I think it was just the display. I had this bug before. So you can right click here and you can do swap function for selected node. And in here, we have this little widget that shows up and I can look for FK. And here I can see all the functions available. And obviously we have the CRFL util that we want to use. So I'm going to click on construct FK and I'm going to hit next and close. And look at this. It has swapped this function automatically for me. It's using the CRFL utils and it has reconnected all the nodes nicely. So we're going to do the same for our backward FK, swap function, and find the backward FK into our CRFL utils and close. Stunning. Our module here, almost there, but hey, we don't need those functions anymore because we're using from the CRFL utils. So let's just clean this up and delete it. Compile. Beautiful. Go back to Mr. Robot. Is everything still working? Yeah. I like to go back and forth between my module and my modular rig when I work, but you can also already like see the result into your module viewport here, right? And play with it. Nice. Well, look, guys, we have a very clean module. The only thing we have is a bunch of variables that are properly categorized. We have all of our graphs, nice and easy. and they are using the CRFL utils functions. So I'm very happy with this. So we're actually going to. So here is what we said. We went and we swapped the FK backward, forward, and construct with the swap module. And now we're going to go back to our root module. Okay, we can start now that because we have this shared function, we can use these functions for our root module. So as I said, the root module needs to create this little global here and local control, and also this body control here. Okay, so far so good. In terms of connectors, what do we need for this module? Well, we need a root connector to define the root bone because the root bone needs to be driven by the global control. But we also need a body connector. And this body connector is not going to be optional and is not going to be an array because we need to make sure we specify at least one bone that this body control can either snap to and drive, you know? And then we have this new connector that is hip bones connector. And this one is a little special. This one is actually optional. And on top of this, it's an array. Okay, so the reason why we want it to be optional is that if we don't specify the hip bones, we can use the body connector to snap our body control. Okay, but if we specify the hip bones, then we want the control to be snapped onto in between the hip bones. So let's do that and let's create this module. So we're going to go back to day 4, modules, right click, animation, control rig. And again, this is a module. It needs a graph. I am clicking on control rig. We're going to call it CRM root. Open this bad boy. There is nothing in it. Makes sense. We're going to swap the preview mesh. Now we have this beautiful little character, but again, rig hierarchy is empty, and it's because we need to switch it to rig module at the top. 3, 2, 1, let's go. Okay, we have our primary connector created. We can drag and drop it onto the root, stunning, and then we can create our body. So new element, new connector, and we said the body connector. The body connector is not optional. And is a child of primary, sure, because it's going to be the root anyway, so that's fine. And then we have the hip bones. So I'm going to scroll down, find my first hip, right click, new connector, and rename this guy hip bones. And this one, as I said, is a little special, optional, and I want it to be an array. I don't want for like it could be the child of primary, doesn't matter in this case. So now that this one is set as an array, I can hit this little plus button and I can say, give me the other hip. And if I scroll down into my list here and see that now this connector, the same connector is assigned to 2 bones, which is perfect. Okay, nice. So we have our connectors, and what we need to do as usual is store them into variables. So into our construction graph, we're going to go and we're going to do get connections. And we're going to store that into variables. So promote to variable, this is going to be the root. And we're going to do the same with our body. Promote to variable. And we're going to do the same with our hip bones. But do you remember we said, hey, this hip bones is an array connector. And when I use the get connection, it's only outputting a single item. So that's not going to work. If I said this, it's only going to return the first one of that array. Don't worry, guys. We got you covered. We have a get array connections. And this is returning a list of items. Perfect. That's what I need. I'm going to store these hip bones into a variable, promote to variable, and compile, and then do a bit of cleaning. Nice. And then what I'm going to do is rename these. So the first one is our root. Second one is our body. Third one is the hip bonies. Okay, compile. Nice. I am not going to create the connector event for this one. I'll let you do that, but I hope you get the sense of it. Okay. So now we have the connectors and they are stored into variables. We obviously need to create our logic. We need to spawn our controls. So let's go and steal more work. Okay, we go into day 2 and in the construction event of day 2, at the top here, Ferris is creating the global control and he's storing it into a global variable, creating the local, storing it, storing some metadata, using the hip bones here to define the position of our body bone, a body control, storing this, and storing some metadata. Okay, well, you know what? Let's grab this. Let's copy this whole thing. And then I'm going to put it on the side. On the right, it's Ferris. On the left, it's our CRM root. I mean, it's not quite fair. It looks a bit like Ferris, but no. It's his work only. Okay, so we have now I can in the construction event, I can paste. I can copy maybe the very first and then paste. Oh, okay. Okay, guys. So you see here, there's a bunch of blue item here that is not when I paste it. This is not quite ideal because when you're copying graphs like this, if the variables don't exist, it's actually not creating them for you right now. We're going to create a ticket for this, I promise. So we're going to have to actually create those manually for now. It's okay. So we have a global control, local control, and a body control. Those ones are just rig items. So let me just do this. Global control, local control, body control. We have them now. I'm just going to delete this, no point. And I'm going to paste again. And look at this. Yeah. We have all of our variables here. That's good. And if I come here and I clean this up a little bit. So let me just create a sequence node. And the first one is going to be where I define my variables. So I need to define them first, obviously, if I want to use them. And I can connect this. Okay, cool. Awesome. You can see that now we have our controls created and this is nice and easy. Okay. But wait a minute. If we look at this, okay, we're creating the global control. So far, so good. Creating the local controls, storing them, that's fine. Hey, wait a minute. Here, we are setting item metadata. And this is red. Okay, that's fine. But these ones aren't red, so that should be fine, right? Well, not quite, because remember, this hierarchy is imported procedurally. So if I change this and the names are different, well, this is going to break. So we have stored these heap bones into a variable. We need to make sure we use it. Same with the root. So now that we have those variables, we can do get root. Here we're specifying the metadata on the roots. So we do this. We can do get heap bones. We use the heap bones in here. Perfect. Here, this is the body bone. So get body. Nice. And keep going. And yeah, let's go. We have another one here. And body and compile. Okay, nice. Let's go into Mr. Robot. We now have a beautiful CRM root that I can drag and drop onto the root bone. And you can see it's not automatically specifying the body or the hip bones, but it's okay. You can work on this if you like. So I've specified the body. Okay, and you can see something pretty weird here. So let me just delete this so it's clear up. You can see that the body control is at the origin. And it's probably because we haven't specified the hip bones, right? But let's do some a bit more logical way of dealing with this. If we haven't specified the hip bones, I want my control to be at least on my body bone. Okay, so we can do that. The one thing I want to show you first is the hip bones here. We said the hip bones is an optional connector. Okay, and this is why this module is able to resolve. So this is why we're actually seeing those controls. If I go into the root module and I go into my hip bones connector, into the details panel, and I turn the optional off and compile. I go back to Mr. Robot. My controls have disappeared. And my controls have disappeared because this module is not able to resolve anymore because the hip bones have not been defined. So it tells me, hey, you're missing the hip bones. It's in yellow here. I don't know what to do with this module. So either you specify it or I just can't work. So in our case, because we know we want it to be optional, I'm just going to put it optional. And then now I have my controls. But what I want to do is add this extra logic that this will snap it onto my body bone. So if we go into our root module and where we're creating the body control here, we're doing this fancy stuff here. We're looking at the body bones and we are basically getting the average position of our body bones. Yeah. Well, what I can do is do the get connection, get array connection again. And on this get array connection, I can specify my hip bones. And we have this little pin here that is said is connected. So if there is no hip bones connected, then this will be false. So what I can do is do if it's connected. Well, obviously, I can use the average position of my hip bones. But if it's not connected, I want to specify the location of my body bone. So I grab my body down here, translation, plug it into the false, and then the result of this if would go into the translation of my body control. I compile. If I go to Mr. Robot, look at this. We have our body control onto our body bone. Our module is still working, but the hip bones are not even defined. So that's awesome. That's a great way to use optional connectors. Now I can come here and say, use the hip. I can add a little more here, use my left hip, and then gone. Our body control is between our hip bones. So that's a great way to use the optional connector and to use the array connector here. So nice and easy. But again, this root module is not doing anything because we haven't specified the forward and backward. So I know that we have this beautiful forward FK function that we have into our CRFL utils. So I'm going to use that. And the bones that we want to drive are the body and the root. So I'm going to just go into this forward solve and say get root and get body. Nice and easy. And then you can add items directly into the array like this, maintain offset, and then hit the forward solve. Now, if I grab this and move things around, I love it. This is working. Now I can go into my blueprint and I can create a new graph, backward solve. Nice, it has renamed it for us, and backward FK. Super simple and still super powerful. Okay. Cool. So that's nice and that's nice. Nice, guys. So we have two modules. Well done. That was pretty smooth, right? But now I want to tell you about. So sorry, yeah, quickly, we've created those modules. We created the root module, sorry, we've stored our variables at the top here. We've spawned our local and global control, created all of our variables first, because if not, it was busting when we copied stuff over. We made sure that the optional hips connectors are creating this cool little logic here that it will be snapping it on the body bone if they are not existent. And then we use the forward FK and backward FK function. Okay, cool. So we have our two modules, but now I want to talk about module metadata. Okay. And module metadata, think about it as basically you want your modules to talk to each other, okay, without having to expose a bunch of attributes at the top level of your modules. You don't want to create like 15 different connectors and things like this. If sometimes you just want to say, hey, just find me the global control or something like that. Well, a good example of this is also, let's say I want to define three main colors. I want to define the central, the left, and the right color of our modules. Yeah. I want to define them in one place. And when I change that value at that single place, I want this to trickle down to all of my modules very easily. Okay. So in order to do that, in our root module construction event, we are going to set some module metadata. Okay. And we are going to create three different variables. So global central color, right color, and left color. We're going to make these public. So then they will be accessible on the top level of our root module. So we can set these values. And then we're going to set these values into the module metadata. Okay, so let's have a look. We go back to our root module into the construction event. We are going to firstly create our beautiful variables. So global central color, and then linear, it's going to be a linear color type. And we're going to make it public right away. And we're going to duplicate this, call it right color. And this one, call it left color. Okay. Again, I don't like this. This is dirty. So let's make this clean, create a private category, drag and drop all of these in here. And then we make a beautiful module options category, drag and drop, stunning, and reshuffle things a bit. Nice. We have our three here. We're just going to specify some default values. So if you click on the color and you can specify for the right, we're going to say red. For the left, we're going to say blue. Pretty basic. Okay. Compile. So now we've got these things. If I go to Mr. Robot and click on my root module, I have this accessible here and I can click on them and change them. That's nice. But then we need to store these into the metadata. So then other modules can read this metadata and adapt their colors. So let's go and create this set module metadata. Okay. So I'm going to grab this global control color and I'm going to drag this into the value pin. And here, set module metadata, you are familiar with the set metadata already. You guys have been working with this. And here we can see the difference. The set metadata is having an item as an input pin. So you're basically setting some metadata on the item that is specified here. As you can see, the set module metadata does not have an input pin or an item pin. And the reason why is because simply the item is the module itself, right? So you're basically setting some local information to this module that will be accessible by the other modules. So the other thing I want to mention, so obviously you have to specify the name first, is in this case, central color. So I'm just going to name them the same, but this one is important. Make sure you don't have any typo or anything in here because this is how you're going to access it from the other modules. And then the other things that we can see is that we have a namespace and we have self, parent, and root namespace. What does that mean? Well. So if we look at the rig hierarchy here on the right, we have a top module, a spine module, and a finger module. Let's say we are currently into our finger module and we're working in the construction event of our finger module. And I'm using this set module metadata. Well, if the namespace is set to self, it's going to simply set the information onto the module itself. Okay, so the finger. But within this finger, I can also set some metadata on the parent module if I want to, or even on the root module if I want to. So modules can add metadata to the root module that other modules can read as well. You don't need to be in the module to add the metadata. You see what I mean? So I am in the finger here, and I'm adding information onto the arm when I'm setting this to parent. And I'm also setting information onto the top module when I am on the root space here. So the namespace of root means the top module, the one that is at the top of your hierarchy, okay? It doesn't need to be called root or anything, but just the namespace is called root. Okay, so in our case, because we know that our root module is going to be at the top of our hierarchy, we want to set this to self because we want to set this information on the current module. So let's do that. And what we're going to do is we're going to duplicate this. We're going to create all of them, obviously. Set module metadata. and set module metadata. And we're going to set the same for the global right. And we're going to set the same for the global left. Okay, okay. All right. So grab these three OCD. Oops, that was the wrong button. Shift S, Shift S. We're going to make sure we are actually setting these variables name, because if not, we're not going to be able to access them. Set global, set, yeah, global right color and global lefty color. Yep. Set these ones. And we're going to add a little pin to our sequence node at the top to keep things nice and tidy. And so here, usually it's nice to just create a comment box and, set metadata and change the color and make it pretty. Anyway, okay, so we have this now set into our module. It's great. But how do I access it from my other modules? What about if I am here in Mr. Robot and I grab the FK chain and I drag it and drop it onto the left leg? And I want to say, okay, well, now just pick up this left collar because, well, that's what you're meant to be. But what I would need to do is I want to, for example, name my module left leg. Okay, what I can do is based on the name of my module, I can query the corresponding color from the root. In order to do that, we are going to create together this override color from module metadata function. And what we see here is the first thing we're doing is we're getting the module name and we're checking if the module name starts with R space. That's our naming convention. And if it starts with R, we're getting the right color. Okay. And if it doesn't, then we're getting the central color. Then we're doing the same for the left. And then we're splitting this out into the color of our shape setting. Then this function will be reused for all of our construction events. And so it needs to be public. Okay. So let's just do this together very quickly. We go to our CRFL utils because that's where we're going to store our public functions, override color from metadata. And then let's put this into a beautiful category straight away. CRFL utils and metadata. And we're going to make this public. Okay, this function's empty. I need to start building it. So we are, as I said, I want this to be based on the name of my module, right? So I'm going to do in the CRFL utils, I'm going to go get module name. This is super handy. This would return the module name, and I can say, hey, if you start with R space, then get module metadata. And the module metadata that I want you to get, I'm just going to do a little hack here. You can use a from string, so it would be easier for me to copy things over. Global right color. So that's what I said. This name is important here because that's obviously need to match exactly the metadata that you're querying. And here we're going to have to specify what type of metadata that is, which is a linear color. So I can right click on this and set this to be linear color. The output pin will just change. And then the default value, basically, if it cannot find this linear metadata, it will back up onto this default value. We don't need it for now. So if it starts with R, if, then grab the right color. Nice. Okay. But if it doesn't start with R, well, right now I won't like to take the central color. Okay. Nice. We can do the same with the left. So I grab this whole graph here, Control C, Control V. If you start with L space, then grab me the left color, please. Thank you. And we can do another thing here. We can reuse that if. So we're going to move this up a bit. And we are going to say, if you're not starting with L, grab me the result of my previous if, right? So let me just make this a bit more clearer by this. So start with R, great, it's true, returns this. If it's not, returns the central color. But if you start with L, grab the left color, and if not, get the result of our if here. Perfect. Okay, so this is giving me a color, but if I look at our FK chain and go into the construction event of our FK chain, we can see that we're passing a shape setting. Pretty nice. And this shape setting has multiple options into it, multiple things into it, and it has the color. So I want to override this color here. The easiest way, or what I would like to do, is from the shape setting, I want to call this override function. Okay. So what I'm going to do is I'm going to create an input to that function. So if I click on the execute context and the entry here, sorry, I can at the top add a new input that's going to be called shape settings. And this one, sure. And then here, the type of it will be rigging hierarchy, add control shape settings. That's fine. Now I can use this as an input. And then I want to obviously spit out the same. So I'm going to, in the output pin, I'm going to create a new one. I'm going to call it value because they can't be named the same. Obviously, the input and output. If not, the function would get confused. So, and this one will be same type. So shape settings. And what I can do now is I want to grab the input of this and I want to override the color. Okay. So what I'm going to do is just look for shape settings and you see here input arguments. So this here is exactly the same as me putting this pin, but it's just a bit cleaner. So I've got the shape settings. And as I said, the output, I want to output everything but the color. Okay. Because the color that I want to output is what I am calculating here. Nice. Okay. Compile, go back into my FK chain. And then here, technically, I should be able to pull this and say override color from metadata. But what you see here is that I have to execute this function. And if we look at the function itself, we're not actually using this execute pin at all. So let's make it even nicer. Let's go into our detail panel here and let's kill the execute context. Okay, that's very nice and easy. I can compile, go back to my FK chain, and look at this. I don't even need the execute anymore. Let's go, and I can plug this in, compile. And I can go back to Mr. Robot, and now I can cross my fingers, and it's not working. Okay, so why is this not working? I think there is two things. First, we need to make sure that we have named it properly. Okay, it's named properly. Now, if you remember, we said that within this module, so if I look at the FK chain and I am looking at override color from metadata, so this is where it's called, we're doing this get module metadata and we have the namespace self. So it means that it's currently looking for this metadata on the module it's called on. So it's looking for it on the FK chain module. Obviously, this is not going to work because we've set it on the root module. So we need to change this onto our top level module, which is our root, and we need to compile. Okay, now go back to Mr. Robot, and it's still not working. Why? Well, I pretend, but I do know the answer. Okay, the reason why is because both of these modules are on the same level. So when we go in here and we look for the root module, the top module metadata, it doesn't find any because this module is already at the same level. So if I drag and drop this guy, check out the colors of our controls. I might have to compile a bunch of things first. Look at this. The colors has changed for us. I can now go into my root module and I can change the colors. And now we have a beautiful module talking to the other module, just using module metadata. So it's a pretty basic example, okay? But it's super powerful. It's super powerful to pass data between your modules in a very clean way, you know? So that's pretty nice. I think we are happy with this. What I don't like though is the colors of this root module. So I'm going to go back into my root module. And now that we have this global central color, I can use this global central color straight away onto my shapes. So for the global, for the local, and for the body. Okay, guys, we have two beautiful modules talking to each other. We've learned a few basics about connectors and everything seems to work nicely. Beautiful. So we're gonna take the work done by Ferris again, steal everything and make it a module. And the first thing we're gonna check is the module requirements, the same as we've done with the two other modules. And when I took a sneak peek at what Ferris has done with you guys, you have worked on a construct limb function, a forward limb, and a backward limb. And we can see they have tons of inputs, which is fine. We're just going to have to make sure we have these as well. And within those functions, we are using shared functions, the construct FK and backward and all that stuff. But also we're using new functions such as the backward IK and the compute pole vector. These ones, they don't need to be shared across because they only would be used in the current module, which is the limb. So we're going to keep them as local functions. And again, here, I like to decouple all of these inputs into two different sections. So we got the different inputs that would be used for the actual module logic, as in the bones, the parent, and the IK parent. So these ones will have to be connectors or defined by our connectors. And we have the module options, which are what needs to be exposed at the top level of our module for it to be flexible and modular. Okay, so let's do that. But the next stage we are going to look at first is the limb module connectors. What do we need for this module to work? We need a start and end connector so we can define where our limb is starting and ending. And we need a parent connector for where our FK controls are going to be parented, and an IK parent connector for obviously our IK controls. So this looks pretty similar to our FK chain module. So we are not going to recreate this from scratch. We can duplicate this FK module. We can call it limb 1 bone, 2 bones, excuse me. Open it. And what we need to do is we need to clean up a bit of the logic in the graphs because we don't need this logic. So I'm going to delete the backward solve logic. I'm going to delete the forward solve logic. And in our construction, I can delete this stuff here as well. But what we see is that we have most of our connectors and we want to create the IK parent connector. So I'm going to click on the hip, right click, new connector, and we're going to call it IK parent. First thing we are going to do, as always, make sure that we check the options. So it cannot be optional. We need to define it. And it cannot have the child of primary rule because it would be above our primary connector, which is our start. Gonna delete this. And the second thing we need to do is always store your connectors into variables so you can use them across your graph easily. So we're going to grab this guy, get connection, and we are actually going to set the IK parent in here and promote this to a variable. Go back into our blueprint, name this properly, IK parent, and store this into our private section. Actually, it'd be awesome if when you pull from the get connection, it renames this variable automatically to the name of your connector. New ticket incoming. Okay, so we got that. That's fine. And obviously now we want to build the logic of the construction logic of our limb. So we're going to open day 2 again, the robot day 2 from Ferris. And we're going to quickly go through this awesome function, which is our construct limb function. Okay, so the difference between this one and the other modules that we looked at is this construct limb. I could technically copy this and paste it into my module, okay? But why do I need this function? I could have all of this logic straight into my construction graph instead. And this would make it make sense a bit later, but then you would just deal with your graphs and all your logic would be in your graphs. It's quite nice and it's easy to go through that. So that's how we like to work when we've been working on modules for quite some time now. And it has proven to be pretty nice. So that's how we like to teach it. So if I look into this construct limb, there's a few things that we need to double check. Okay, we need to have all of these options that are used across this logic created before we start copying things over. If we start copying this, half of it's not going to work because, well, it doesn't know where to find those inputs. Okay. And also, same thing here. This function has some local variables. So we need to make sure we have these local variables. So when we're creating the FK controls, we're storing them into the local FK control. So we need to make sure we have that. So let's copy these first, and then let's create all of our inputs. It's going to take maybe 5 minutes. Okay. Righto. So that's Ferris's work. That's our limb module. I'm going to just Control C, Control V these guys. One day we will have multi-selection. We've been asking for it for quite some time, but it's all good. Take this opportunity to remind them. Uh, okay, so we have this. That's good. I have turned them off to be public because they need to be private. They don't need to be exposed to the top level of my module. And we're going to look into all of the entries here. So we said we got prefix. We won't need it for now. I will get back to it in a minute. You will understand why. Bones, we have our bones. We store them here. IK parent and parent, we have them as well. So that's good. And then we need those things here. So secondary axis, I'm going to create a secondary axis. And this one is a type vector. And while I'm at it, I'm going to create the primary axis because I know I will need it later. So primary axis. Nice. Then we have the FK rotation order. And if you remember, we have duplicated this module from the FK chain. So we already have a few variables that are existing here. So we can just reuse this for now. So I'm going to rename the rotation order to FK rotation order. I can see that I have the IK rotation order. I'm going to duplicate this and rename it. IK rotation order. Then we have a pole vector offset. So pole vector offset, we can create a new variable, PV offset. And this one is a type float, so that's good. And then we have FK shape setting, IK shape setting, and pole vector shape setting. So remember, we already had a shape settings for the FK. So I'm just going to rename this and duplicate it and call it IK for this one, and duplicate it again and call it pole vector for that one. Nice. And lastly, we have this initial IK FK mode Boolean. Remember, we had this maintain offset for the FK chain. We don't need it anymore. So let's just rename this guy IK FK mode. Nice. I can compile. No errors, makes sense. And then now I'm going to go through Ferris's function and make sure that I understand it, obviously. First thing he's doing with you guys was using the construct FK to obviously build our FK controls. That's fine. But we have this into the construct, the CRFL utils, remember? So we're going to have to swap this, and that's all good. Then we spawning the IK control, storing a bunch of stuff into variables, storing some metadata. So far, so good. And then we're creating the pole vector as well here using this compute pole vector location function. Okay. We're adding the attribute, the IKFK switch attribute, and storing this and setting the channel host. That's good. And we're adding the space. Nice. Okay. And then we're returning all of this. Okay. So you know what? I'm going to take everything here. But actually, I am not going to take the return of this function. And because I am not going to paste that into a function, I'm going to return this, paste that into my graph directly. So I'm going to hit Control C here. I'm going to go into my little construction event. So this is my graph. You see, I'm in the construction event graph and not a function. And I'm going to paste this bad boy. Okay, when I paste, it's telling me, hey, you're missing this construct FK function. I'm just going to say yes. Hey, you're missing this compute pole vector function. I'm going to say yes. So it pulls them for me automatically. Nice. So let's make this bigger. So it has copied everything. So let's go through it and make sure that things work. And as I said, we have this construct FK. Well, we know that we can swap it to our beautiful construct FK in our CRFL utils. Very nice and easy. Boom, it's done. You see, very quickly. Okay, then the thing here is here something is busted, but because we haven't put the prefix, and I will show you why we are not doing it. So, so far so good. Here we're storing the metadata. Here it has copied the compute pod vector function for us. Here there's the prefix issue, but it's okay. And add attribute, IKFK switch, everything seems to be there. Beautiful. So we are going to shuffle things around here because the first thing we need to do is actually set our variables so then they can be used, right? Then we can grab our construction and we can use it there. Beautiful. Move things around, technically put a comment box and name this define variables, maybe. Okay, whatever. Or store connectors, whatever you want. We compile this. I go into my graph here in my viewport and look at this. Look at this. We have beautiful controls. Beautiful. I don't really know if they're that beautiful because when we duplicated the FK shape setting, well, all of these have the same now, the same default value. So let's go into our IK shape settings and let's change it to, I don't know, I think that was box thick. Yes. Okay. Let's check those values quickly. If we don't have, yeah, we have a transform in the rotation that we don't need. And the pole vector, I like to use the diamond solid. His diamond solid is a bit big. And also we can see that it's in the center of the knee here. So it should be offsetted. So let me just change the shape settings here briefly. If you click on this little icon and you just set one value, it sets it for everything, which is nice. And what I want to do is set a default value for my point vector offset. So I'll set 45. Seems to be pretty good. It's a right distance to my point vector. Okay, nice. I can compile. I can go to Mr. Robot and I will delete this FK chain module. Now I can see I have a beautiful limb two bone that I can come and drag and drop and bang on. Okay, so what do we see here? First thing is the start connector has been found properly, the parent as well. The IK parent is not automatically found. Well, we haven't added that into our connector event. So let's do this. But also what I can notice is that the end connector is finding the last bone of the chain. I mean, it's cool for a FK chain, but it's not that great for a limb module. Usually a limb has two bones, So let's find only the index 2 of that array instead of the last one. So if we go into the limb 2 bone, in the construction event, in the connector event, if I zoom in a bit here, we're defining the end connector, and then we're getting all the children. And on top of this, we're setting -1. So I just wanted to set it to 2. Okay, so when I said 2, it means that because I have set to, I need to set this to include parent. So when I look at the start, it's going to include this bone as well in the list. So 0, 1, and 2. That's the index to get this bone. Okay, and then here we're setting the parent. So I want to do the same with the IK parent. Okay. I'm going to grab the IK parent here. Beautiful. And it's going to set it from the parent of the start. We good. We're going to, oopsie, we're going to take this guy. Yep. And compile and go back to Mr. Robot. Try again. Drag and drop onto our limb. And boom. Look at that. We have a limb working. Not quite. We're only doing construction. But also what I can see is that these options are pretty messy and some are missing. Yeah. So let's clean this up first. We go back to my blueprint. We can see FK shape settings. We can see secondary, primary, and offset. They need to be public as well. And I would like them to be in the module option. And here, the order is important because the order that you see here is the order that's going to be displayed in the modular rig interface. So let's move things nicely. I like to have my primary, secondary axis. These ones are important. We'll understand soonish. And then we have point vector offset, the initial, the FKIK, and then the shape settings. If I compile, go back to Mr. Robot, beautiful. Everything is nicely set in here. I like that. Okay, cool. Well, this is great. But now if I grab this and move it onto the right leg, and let's call it left leg for this one. And let's call it right leg. And I have to drag and drop these into my root module. Well, my right leg is not picking up the color. And simply because we haven't used our beautiful override color from metadata function. So if I go into my thing here and it's using the construct fk here, I can go and say override color from metadata. Yeah, that's going to be fine. My fk controls already have changed colors. And I need to do the same for my ik and my pole vector. So at the bottom here, like this and like that. And very quickly, we're doing this for the pole vector. It takes a second and it's going to be beautiful. If I compile this, go back to Mr. Robot. Look at this. Stunning. I have my beautiful colors that are defined on my root module, and I can change them very easily. So our modules are already talking to each other, Very nice. Okay, but this module is not doing anything because we don't have any forward solve. So let's go into the forward solve. Open Mr. Ferris Day 2 and look at the forward limb function. Okay, this forward limb function looks pretty decent. Let's quickly look at what are the needs for these functions. We have FK controls, IK controls, and pole vector controls. That's all good. All of these we have. However, if I recall correctly, they are not named the same. So if I start copying this whole graph, and these are called local FK, but he's looking for FK controls, this is going to break. So let's make sure that we rename those first. Okay, we just remove the local from it. All right, we good. Okay. Then the other thing I need to double check is this function use any local variables, right? And the best way to look at it is scroll down in the rig, in the My Blueprint section, and I can see that this is using the local IKFK mode as a local variable. Same thing again. If I copy this graph and don't have this, it's gonna go poop. So let's take this and let's copy it on my module. Okay, I have it. I don't want it to be public. That's fine. And then now I can go through this function and see what is Ferris doing. Okay, we have the switch IKFK here. So it's basically saying, hey, take this attribute, which is on my IKFK control, and set it into a local variable. That's fine. That's what we just copied across. Here we're doing the control visibility, nice and easy, nothing too fancy. Here we're doing the solve for the FK and the match IK. Okay, so we have two functions. This one is used for from our CRFL. We'll have to swap it. And this one is a new local function. So we will need to get that as well. That's fine. Solve IK. So we're doing the IK solve, the pole vector line, and the backward FK. So this one is a shared function again. And then we're doing a bunch of stuff with the keys. Okay, that's fine. I can grab everything, but I am not going to grab the entry, and I am not going to grab the return because we are, again, going to copy this whole logic directly into our graph rather than copying the function itself. Oops. So I'm going to put Ferris on the right. I'll put our robot here. And in the forward solve, zoom out, paste. Okay, here it's telling me, hey, you missing the forward FK? Sure, take it. You missing all of these functions? Sure, take it. Just have fun, take it. Okay, cool. Got a bunch of red. It's because I need to compile. And seems that we have everything or almost everything. Okay, so we have our forward solve here, and I'm going to expand, I'm going to expand this and go through it very quickly. So we have all of this. That's cool. We have the control visibility. That's awesome. And here something is broken. Okay, that's fine. Forward FK, we said we need to swap it. So let's use our one from the CRFL very quickly. Boom, done. Now, what is missing here? Match IK. So if I look at Ferris's work, in this section here, he's using the backward IK. For some reason, when I copied this, it didn't take it. Don't ask me why. We'll check and try to repro this. Okay, so I copy this function and paste it into my module. And so I can go back to my construction event, my forward solve. And now I can just use this. So I have all the variables. So I just drag and drop the function, and I will just quickly reconnect the nodes very quickly. Yeah. Okay, nice. Now we got the IK here. Everything seems to be there. And the match IK, that's fine. And the keys. Okay, cool. I can compile. And then now I can set my forward solve and connect it. Okay, still has done something. And let's have a look. Can you please cross your fingers really hard for me? Are you ready? We're gonna grab this IK control and we're gonna move our leg. Not quite what I was expected, but actually, yeah, it was expected. Okay, so the reason why is we have created this primary and secondary axis, right? We have created from scratch in these using the variable plus button here. And these ones are used for the basic IK solve, but they're all set to 0. So the basic IK here doesn't know how to resolve that leg. So we need to make sure that we set this properly. And the primary axis is x1, and the secondary axis is z1. Okay, compile. For this specific module on the left leg, it's working. Nice. Perfect. Okay, that's awesome. Let me just grab Mr. Robot. And now I see I have these two legs here, and one seems to be fine. The other one doesn't quite look like it's working. Well, the reason, again, is our beautiful primary and secondary axis. And that's why this is super important to expose some attribute and arguments to your top level of your modules. So then you make them really flexible. Now I can grab this and just set it to -1 and set the secondary axis to -1. And I'm using the same module to build my left and my right. So very simple, very easy to set up, you know. So this is great. I'm happy with this. Now let's have a quick look because I think I'm forgetting something. So I think that Ferris is doing something here. It seems that something is missing. So let's have a look and why it's missing. Okay, so we open this guy and we are in the forward limb function again. And at the bottom here, he's using a previous IK FK switch. So you see what I've done? I forgot to create this guy when I copied things over. So if I did that, obviously it's not going to copy that and just doesn't know where to take it. But what I'm wondering is, what is this previous IKFK doing? So let me just make sure that I have this right. So I will look for previous IKFK switch. And when I look like this, I can see that it's used. It's passed quite a few times into those forward limb functions. Okay, so in the forward limb, it's used as an entry and it's only used once. So that's fine. It's only used once in this place. But what's tricking me is that it seems that it's getting passed through as an input. So it must be doing something else after, and he is. So within that function, we're doing something else after in order to set this previous IKFK. So we need to make sure that we also set this into our current module. So let's have a look. We're going to have to create it first. So local IK, I'm going to duplicate this local IK and I'm going to call it previous IKFK switch. And we're going to reuse it here. And what this logic is doing is basically checking if the local IK, so which is basically this attribute here, right? When we click on the IK control, we have a channel, which is the IKFK switch, okay, which allows us to switch like this. It's checking if this is equal to the previously set IKFK switch. And if it's not equal to it, we want to create some keys on our controls. The problem here is that we are never setting this previous IKFK switch in our module. We need to make sure that we are setting it, because if not, this will always be 0. And when it's in IK mode, it will create keys all the time. So we're going to copy the value of our local IKFK mode. And when this is not equal, after it has keyed everything, we're just going to set previous IKFK switch. And we're going to set it as the current value of our IK. So now if I compile, and when I will drag this into a sequencer, it would only create keys when I switch between the two modes. Great, that's awesome. So we have this limb we just need to get the backward limb function, and that's just going to take 5 seconds. Okay, backward limb function, we go back to day 2, backward limb. It's only using the backward FK, which is a shared function, and the backward IK that we already have. So let me just grab just the variables because I can hook this up quickly so it doesn't tell me to copy those functions again. I go back to to the CRM limb bones, and I will go into the backward solve. And here I'll just paste these guys. And the first one we said that was the forward FK that we use from our CRFL. And the next one is the backward IK. Okay. Nice. I hope you guys are still alive. We're almost there. Okay. We have our module that is done, talking to the root module already, but there's a bunch of functions that have been copied over that I don't need anymore because we've swapped those, right, to use the CRFL. So let's clean this up. We kill the conform name, we kill the construct FK, forward FK, backward FK. We keep the backward IK because this one is only a function that is not into our CRFL. And also here I can see that it has copied the compute point vector location twice. And I'm wondering why, but so let's have a look. And you can right click on the function and say find reference by name. And we can see that this is used here in the construction event. And this is the actual function. And it's used in the backward IK as well. Okay. But why is there _1? So if I right click on this one and do find by reference by name, I can see that this is only the function definition. And this function is not used anywhere. You see, if I double click on this, it just opens the function. So I don't need this anymore. Clean it. I can just delete it and compile. Make sure that my rigs work. Nice and easy. Perfect. Look at this. We have a super clean module. Okay. This module has 4 graphs, which contains all the logic. We don't have to dig into the graph, dig into a function. It's very consistent with all of our modules. If you build all of your modules like this, anybody that opens your module will be familiar with it. I think that's the main thing here for us was consistency. We have multiple people working on modules. Here I forgot something. Look at that. I've just found out. But just to touch base on this, we have multiple people working on modules. So consistency is really important, right? So I deleted the match FK. That's why. So the backward FK. So let me just add that backward FK here. Okay, that was it. I forgot to swap it, and when I deleted it, it obviously disappeared from here. Okay, that's awesome, guys. So we have this guy, and we are just going to quickly look into this. So just a very quick recap. We've duplicated the FK module. We cleaned up the graph of the FK module, removing stuff in the construction forward and backward. We've added the IK parent connector. We specified this and stored it as a variable. And then we copied the construct forward and backward function content into our graphs directly. Well done. The limb module is done. Let's move on to the spine module. And it's going to be fine. Okay. I tell you, it's not going to take too much time. I know it starts to be a bit repetitive, but I want to show you this again because there's a few things to take on from that. So module requirements, good. We have a construct spine, forward spine, backward spine. Jeremy has done an awesome work with you yesterday. And this is very simple. We only use bones, parent, shape settings. So when we look at this, that's so far easy. And what do we need for connectors for a spine module? We need parent, start, and end. Again, very similar to our FK module. We are not going to redo that from scratch. We go back to our module folder and we duplicate the FK chain and we call it CRM spine. Open this guy and with same thing, we'll clean some of the logic that we don't need into our forward construction and backward. All of this is gone. We have a clean module ready to work. The first thing I need to do is I need to make sure that my connectors are onto my spine so I can actually work properly onto my spine bones. So I'm going to click and drag this parent connector and put it onto the root. Click and drag on the start and put it onto the first spine first end, which is our body bone. And the last end connector will go onto our upper chest. Okay. Nice. Now we go to day 3. So I'm going to close day 2 and I am going to open day 3. So day 3 is Jeremy here has a beautiful CR robot day 3. We're going to open this and have a quick sip of water first. Okay. And we are going to check the construct spine function. Construct spine function. Grab this, have a look. First thing again, we look at the inputs. We have parents, bones, and shape settings because these are already from our FK module. And here is using a local function called local variable, sorry, called local control. So we need to make sure we have this. And it's an array of rig elements. I'm just going to copy this very quickly, paste it into my graph to make sure I have it. Okay, cool. Look at the functions very quickly here. Spawning the hips, spawning a hip null, spawning the chest control, spawning the chest null, storing everything into variables. Oh, super easy. Grab everything but the return. Because again, we're going to copy this into our graph to have a very clean module. Copy this, go into our construction, paste. Nice. Everything is copied across. Grab our construction event, move it down, connect it, shuffle this back because we need to make sure that we define our variables first. Defining our variables here. Oops. Connect like this. Sorry. And oops, I'm going to expand that a bit so we can see a bit better. There's a bit of red stuff here, and it's just because I haven't compiled yet. So first we define our variables, and then we spawning everything nice and easy. If I zoom in into my graph here, into my viewport, I can see that there is a control here that has been created. I don't like the shape of this. So you see, let's change it in our beautiful shape settings. And I think this was square thick. Yeah, and there's probably other things that we need to change here. Shape settings, we don't want any rotation offset. And let's make it a bit bigger, like 3.5 maybe. Oops. So here you see I didn't click on this little icon, so we only changed the first one. So I'm going to set it back to 1. I'm going to click on this icon here and set it to 3. And now all of the axes have been changed. Beautiful. That's working nicely. We can see the color here is not quite right. So where again, we're going to quickly use into our construction our beautiful override function. So for the hips and for the chest, hang in there, guys. We're almost there. I promise you. We're going to finally have some fun in the modular rig in a few minutes. I promise. Okay, so this is fine. It's creating my controls. That's great. But again, it's not doing anything. So we are going to check the forward spine, which is into day 3 again. Forward spine function, it's using controls and bones. Okay, so I think we have controls. We do, but it's called local control. So I need to make sure that this is named properly. That's fine. And yes, it's using a local variable called spline. So we need to make sure that we have this as well. So again, Control C, go back into our module, Control V, we have it. Beautiful. These two, they don't need to be public. I'm going to move them, clean this up. And let's have a quick look at the graph. We are taking the controls and creating a spline through them. We are attaching the first bone, doing the twist interpolation, and attaching the end joint. So perfect. That seems to be pretty straightforward. We're going to copy this code, take everything again, but the return, hit Control C, go into our forward solve this time. So I'm going to reduce this. Forward solve, zoom out, paste. Oh, yeah. Everything has worked because we have followed the 3 steps, right? Make sure we have all the inputs, all the variables, and all the connectors. Nice. If I click on this now, I have a beautiful spine. Thank you, Jeremy. This is great. And last but not least, let's just finish this up with copying the backward solve. So backward solve, backward spine. And here in day 3. It's pretty easy. It's only doing a bunch of stuff here, set transform. So I'm just gonna grab this. It's easy. Control C, Control V. Guys, it is done. It is done. We have a spine module. Beautiful. Let's go into Mr. Robot and have some fun now. Finally, we have most of our modules. So now let's do some plug and play, shall we? Okay, so grab the spine and then drag and drop it. I'm going to drag and drop it onto not that. Let's just drag and drop in here so I can just set it manually. So the first one is my spine here, and this looks a bit odd, isn't it? Hmm. So when I set this spine, the start, it has set the parent properly, but the end connector, it has found the last bone of this chain, and it found the antenna. So it's creating a spline over all of these bones, and that's obviously not going to work. So I can simply just set this to the upper chest, and now we have it working. But I want to show you that for the spine, you don't really need to have to find the last bone again. So very quick to iterate. We go into our spine module, into the construction, in the connector event where we're specifying the end connector. And then the end connector, which is at the top here, we're taking the last child. I don't really want the last child. I probably want, I don't know, number 3 in the array. Let's try 3. And then grab the spine, drag and drop, set the first primary connector. That was probably 1, 2, 3, 4, 5, maybe 5. Okay, it's okay. We can say 5 here. Nice. So next time I'll drag and drop. Hopefully this will work. So we have the spine, and we want to make sure that we parent this properly. Okay, what I want to show is this hierarchy here is actually quite important, okay? Because it also defines the order of evaluation of our modules, right? So if I grab my body now and I move my body control, it's not doing anything, okay? If I grab my root here, it's moving everything, that's fine. And the root's moving, but for some reason, it's not moving my spine joint. So let's have a look. When I move my body, I want my spine to obviously follow, right? So what I'm going to try is on my spine, I have this parent here, okay? Which is where our controls are going to be parented under. Well, let's try to put this under the body control, shall we? So I'm going to click on this and hit body. And as you can see, it's actually not setting the body control at all. And the reason why it's not setting the body control is because there is no parent relationship between these two modules. They are at the same level. So this one cannot find the body control. So what I need to do is I need to make sure that my spine is parented under my root. Then the root gets constricted. Then the spine can access this body control. So now I can go into my parent and look for body. If I hit body, my connector here has been set properly. And if I grab my body control and move things around, everything is moving. Beautiful. So we grab the body. This is great, but IK controls are not really supposed to act like this. They're supposed to stay on the floor. So if I look at the leg module, we have a couple of options again, because we've been really nice. We've exposed things. We have this IK parent connector. The IK parent connector, I want it to basically be parented to maybe my local control. So when I move my root, it stays on the floor. So I'll click on this connector here and I will set it to be my local control. Boom. Okay, I'll do the same with the right leg. IK parent, local, nice. And now if I grab my body and I move it around, yeah, it works. It's beautiful. I can drag and drop some cool little stuff now. I have my left arm. You could technically now name it properly, arm. And obviously we need to parent it for the colors to work. So it reads the data from this root. And we actually want it to be probably under the spine because of the evaluation order. I'm going to rename those nicely. So we have beautiful names. That's nice. Again, here the pole vector is at the front. Well, not a problem. We have our secondary axis we can specify. Beautiful. And do that. And also we can build our right arm. I could have dragged and dropped, but also I'll show you what I could have done. Sorry, I must have not chose the right one. This is the right one. Well, I'll drag and drop then. Okay, so right arm. I could have also right click on the left arm and said mirror and look for left and right, and it will automatically mirror the module for me. Here you can see this geometry again is busted, and it's because we have to specify the right primary axis. Nice and easy. Look at that. We have almost a fully functional biped. Again, here we have a problem when we're moving the spine. The IK controls are moving with it. I don't want that. So I'm going to set the IK parent to the local control for my arms, for both of them. And do this. Great. So the schematics, by the way, you can hide it by using Y on your keyboard. So sometimes you want it, sometimes you don't when you're actually wanting to just play with your modules. Okay, cool. So I'm pretty happy with this. But what I notice now is that if I look at my rig hierarchy, I, I can see that this has something called underscore pole vector underscore IK. It's not very clean. Okay. And the reason why is because when Ferris has worked on his version, he needed to specify a prefix, right? Because you need to make sure that your controls have the right prefix here. So this one would be called larm IK. Okay. Well, with modules, we don't need this prefix because the prefix is built in the name of the module, in the module name. So if I go back to my limb2 bone in construction, I want to clean these up. I don't like this underscore. So I'm going to delete this and rename this IK. Delete that. This is the IK null. So I'm going to just do this. And then for the pole vector, I'm going to delete this. That's cool. Pole vector. Compile. Go back to Mr. Robot. And if I look at this now, it's really clean. So my module calls the control IK, and this module is used multiple times into my modular rig. But when I look into the rig hierarchy, I can see that all of these controls have a proper prefix, which is the name of my module. If I change this, it will change the name of my control. So this is very handy. And what I'd like to do now is actually, can I use this spine for my neck? Well, sure. Let's just try, right? So here I turn the schematics off, so I can't see anything. I'm just going to hit Y again. And oops, sorry. But let's just do it quickly. So here we're going to specify the first one to be the head neck env0. And again, this is busted. So let's have a look. Why? The first thing we've got to check is the connectors. The start is the neck 0, that's fine. And the end connector is the eyelid. I don't want to create a spine, a neck all the way to the eyelid. So I'm going to specify the head bone. And look at this. We're using a spine module for a neck. That's pretty neat. Let's rename this. Call it head or neck, whatever you prefer. Parent it under our spine. It takes the control color. That's beautiful. Okay. But there's a few things here. There's always a but, guys. Always a but. Okay. So first thing here is I can see in the rig hierarchy, this one is called head slash hips and head slash chest. This isn't very generic, is it, for a module? So you need to make sure that your control names are kind of generic so you can reuse this module for other things. So if I go into my spine, I want to rename these controls. And in the construction event, I'm going to rename this to, instead of hips, I'm going to name it to start. And this is for the null, so start null. And then this is the chest. So chest, instead of start, we're going to call it end. Oops. End. and no. Okay, compile this, go back to Mr. Robot and check this out. We have a beautiful head start, head end, and we have a beautiful spine start, spine end. How cool is this? Now, what I want to do and what I would like to do for this neck, when I rotate this, it's not really, I mean, it's kind of nice to have this local deformation, but it's not very helpful for the neck. You kind of want this guy to follow up when you're rotating, right? So we're gonna add a quick space to our neck, to our spine module. Okay. So we go back to spine here, and in the construction event, we want to add a space onto our end control, right? So I want to basically go in here, click on my end control, hit tab, and find the space. So then when I rotate this guy, it follows up. So at the end here, we're going to do add spaces, which I think you've already seen with Ferris. But this is basically going to change the hierarchy of our rig automatically. So we are going to set the control to be the end control, because this is the child control, the one that will receive the spaces. And we want to add the start as a space to our end control, right? So the start control is created here and is stored into the controls variable. So I'm going to grab the controls variable and copy this, paste it. And I'm going to grab the first control of this array and set it onto the space. Nice. I can plug this in here, and then we'll have to clean this up a bit because it's a bit spaghetti, Jeremy. Uh, all right, so we go into Mr. Robot and we compile, and then we look at the spaces on our end control. Are you ready? Hit tab, and now you can see the head start. And if we look at this, if I go back into parent, the parent space here, they are at the same level, right? Now, if I hit tab again and set it to start, now the end control is parented under the start. So if I grab the start control and rotate, everything is moving nicely. Well done, guys. Well done. We have done it. We have basically almost a fully functional biped rig. You can still come and drag and drop a bunch of stuff like fingers and whatever. It's super nice. You just drag and drop and you get something working right away. You're rigging live. You don't have to wait for your build script in Maya. Oh, sorry, maybe I shouldn't say the name, but in whatever DCC for your rig to build. You're basically rigging runtime, and this is amazing. So the one thing I want to say is you have done things like the reverse foot and things like that with Jeremy. We don't have time to do this today, but you will have access to the fully rigged modular robot with all the modules converted for you. So we have the reverse foot, can move this around. We have the spherical pose reader for the clavicle, and we also have a little extra FK module, which is called an FK array. And the difference between the FK chain and the FK array is, remember the FK chain, we're specifying a start and end connector. So if I wanted to create a single control, you know, well, I'll still have to specify a start and end, and it will create a control on the end, and I don't want this. So for the clavicle, we have an FK array, and this one is only basically taking a bones array connector. And so for each bones in this array, it's going to create a control and do that. So that's what it is. So you have all the modules available here, and feel free to obviously have a look at it, play with them, and yeah, just enjoy. So we got this. Let's go back to our beautiful slides quickly. Spine module's done. The neck, we've made sure we've renamed everything to be more generic, and we've added the beautiful space. And then we looked at the modular biped, and we've started adding a bunch of our modules and made a kick-ass pose. Look at that. Oh, yeah. All right, guys. There is one last. Oh, actually, no, there's not. There's two. I touched base about the module evaluation order, and this is quite important. Again, I want to show you that we have this module hierarchy here with a root, spine, leg, foot, and arm modules. And you have to really understand that they will run one after the other in this case. So we will run all the connectors events in this specific order. So root, spine, leg, foot, and arm. And then we will run all the construction, then all the pre-forward, all the forward solve, and all the post-forward solves. So this is quite nice. And in 5.7, we have this new window that is called the event queue window, which will show you exactly the order that these are getting solved, and it will also give you the performances of each of those solves, which is super helpful. Okay, nice. So the last subject is module tagging and versioning. And we're all going to have a sip of water because this is an important topic. All right, quick break. Not too much, but just enough to keep going. Okay, guys. So the module tagging and versioning. Yeah. Think about it. We all work in production. We start making a rig. We give it to our animators. They're putting it 500 shots. And even though we are the best riggers in the world, the animators will still ask for some stuff that are going to break the current rig, right? They want some new features. They want something. They want some fixes and whatever. So the challenge here is that, with Unreal, we have this amazing thing that the control rig is decoupled from the actual asset. Okay. But it means that you will use the same control rig for multiple assets and probably a ton of different level sequences. And this becomes challenging because if you have any breaking change, well, you're losing all this backward compatibility. So you need to make sure that you are able to create versions of your modules and your rigs to make sure that everything is still working and no breaking. And this is where module tagging and versioning comes into play. In Control Rig, we can create, and modules really helps with this basically, we can create multiple versions of our modules. Because modules are much more granular, you can create versions and update them as you need into your modular rig. So in this example, we're going to duplicate the limb 2 bone, and we're going to call it version 1. And we're going to duplicate the other one, duplicate it and call it version 2. And in those ones, we are going to set tags. So we are able to set outdated tag and stable tags, okay? And then from this, we will be able to, in the modular rig interface, as soon as we've added these tags, they will show up as being outdated. And we can right-click on them, swap module, and swap to the stable version. And that's pretty awesome. So let's do this very briefly. I'm going to go back to our project. And in here, we're going to do rigging workshop, day 4, modules. We're going to rename our limb 2 bone. We're going to add a V01 to it. We're going to just quickly compile that. I don't want to break. That's fine. And we're going to duplicate this, Control D. Because I have put the version at the end of my name, it automatically version up the name here, which is quite handy. So we're going to open this guy. And we have the limb 1 here and the limb 2 there. So in the V1, we're going to go into the class settings at the top here. And if we scroll down, we can see a variant section. The variant section is where we're going to see all the different modules that are a variant to this module. And if you remember correctly, we've duplicated the FK chain to create the limb 2 bone and the spine module. So it makes sense that they show up here. However, we don't want them to be there anymore because they don't have any relationship. So I'm going to right click on this and I'm going to do split variant from set. And I'm going to do the same with the spine, split variant from set. So now the only variant that I have is the version 2 of my module. That's great. Compile. And then I'm going to add a tag here. You can click here and add tag. And the tag will be the outdated tag. Okay. Those tags are defined in an ini file. You can create the tags, as many tags as you want, So these are the basic tags, and we're using this for now. So outdated for the V1. And if I go into the V2 module, class settings again, scroll down, go to tags, and then set this one to stable. As you can see, the only variant now available is the V1, which is great. I compile, and I go back to Mr. Robot. And what I see is, hey, mate, these four modules are outdated. So I have an option here. I can either swap it directly into this rig, or I can create a new version of this rig as well. If I want, I can duplicate Mr. Robot and call it V2. So then my animators don't have a breaking change in their thing. And in V2, I can go and right click and say swap module. And here it's going to show me the available modules that is a variant to that selected module. I literally click on it, hit next, close, and look at this. The pin has gone. Everything is connected properly. We're using the new version of our module because if I click on this module here, I can look at the rig class and it's showing me which version we are using. So this one is using V01 and this one is using V02. And also you can see the tags as well. A little trick as well, if you click on this class, is actually opening the content browser and taking you to the module, which is quite handy. Okay, so you've got this version stuff. We're good. And guys, just a few things. Lastly, modular rig documentation. There's a bunch of stuff written on this documentation written by Chase. There's awesome stuff here. I was trying to cover most of it, but there are some more information on this that might be worth a look. So please have a read. Again, the control rig resources on the Epic Games library. There's a ton of video. Just go onto the Epic Games library, type control rig, and you're just gonna love it. You know, there's so much cool content in here, and it's just gonna keep growing. And then lastly, a little plug. I did this exploring the power of control rig for animation in Unreal Engine 5.4 last year at the Unreal Fest Gold Coast. And this is going through some pretty cool little control rig tricks, and some stuff again through metadata to user data assets so if you haven't seen it yet, just have a quick look at this. It's pretty packed up with some cool things. And lastly, I want to say, well, thank you so much. Yeah, just thank you for attending this class. I know we've covered, I would say a lot, but at the same time, we've covered the basics of modules, the foundations. We wanted to make sure that you guys understand these properly. Then now we can bolt on and add way more cool stuff to it if you wanted to. So yeah, I would say again, thank you. And if you have any questions, we will be available in, I think, half an hour or something like this. And yeah, all righto, it's done. Cheers.